This is your USB active load resistor. As you can see on the top of the module, there is a cooling fan and a heatsink. Now, this cooling fan and heatsink are used to cool down the transistor at the bottom side of the module. The cooling fan automatically switch on once the threshold level of heat has been reached. So there's no need for you to manually switch on and switch off the fan because it will be operated automatically. Now at the bottom of the module is a transistor. This is now the transistor. Now this transistor is the one that is functioning as the active load for this particular module. This transistor is the one that is responsible in pulling in current from the power bank or consuming current coming from the power bank. The conduction of this transistor is dependent on the amount of bias current entering the base terminal of this transistor. The more the bias current of the base terminal, the more current will pass through between each collector and emitter terminal. The lesser the amount of bias current, the less current can pass through between the emitter and collector terminal. Now, the base current for this particular module is controlled by either rotating this trimmer resistor clockwise or counterclockwise. Now, this module is better than this passive USB passive load resistor in the sense that this module does not have any cooling system that will reduce the amount of heat generated by these two resistors. This was called as a USB passive load resistor because the main component that draws current from the power bank or battery are resistors, and resistors belongs to the family of passive electronic component. While on the USB active load resistor, this is the one that draws current from the power bank or battery. And transistors belongs to the family of active electronic components. The part number of this transistor or the JETIC number of this transistor is TIP 122. This is a medium power transistor. On top of the transistor is an operational amplifier or op-amp. This is a dual op-amp wherein the JEDEC number is LM358 or the part number is LM358. On the side, on the top portion of the module, near the USB connector, is an allocation for a jumper or for a male header wherein it can serve as a jumper that will automatically switch on the fan once this module has been plugged in into a power bank or has been connected into a battery. So you have to solder a male header into these three holes and then put a jumper on the on or on the off position. Now, if you put the jumper on the on position, the fan will switch on once you have connected the module to a power bank or power supply. On the side is an LED, okay, SMD LED, serving as a power on indicator. I am now going to connect the USB active load resistor to the output of the USB doctor. The USB doctor will display the voltage and the current, and the USB doctor will be connected to the output of the power bank. The USB active load resistor is now connected to the USB doctor, and the USB doctor now is connected to the output, to one of the output of the power bank. As you can see, the output voltage coming from the power bank is 5.04 volts DC, and the present current consumption of the USB active load resistor is 0.36 ampere or 360 milliampere. You can now adjust the current consumption of the module by rotating the trimmer, the shaft of the trimmer resistor clockwise. So if you try to rotate this clockwise, the amount of current being consumed by the USB active load resistor is increasing. If you try to rotate the shaft of the trimmer capacitor counterclockwise, the amount of current will lessen, as you can see on the display of the USB doctor. The fan has automatically switched on. Okay, hope you can see it on the video. Okay, the fan is now running. Okay, it means to say that the threshold setting for the heat has been reached, and the fan will automatically switch on to cool down the transistor at the bottom side of the module. Okay, the fan had stopped, meaning to say that the amount of heat generated at the bottom or on the transistor was not able to reach the prescribed level, so the fan automatically switch off. So let us now increase the amount of current to 1 ampere, and let us try to see whether the output voltage, which is 5 volts, will reduce or will stay at exactly 5 volts. Okay, the output current now is 1.06 amperes. As you can see, the output voltage remains at 5 volts. The cooling fan is now working or had been activated. Okay, let me turn it on its side. Let us now set the current to the maximum limit of the power bank, which is 2 amperes, and try to observe whether the output voltage changes or reduce. I am now turning the shaft of the trimmer resistor clockwise. The output current now is 1.66 ampere. Okay, that's it. The output current is now 2.03 ampere. And the output voltage is still 5 volts or 4.99 volts DC. Now, basically, the USB active load resistor is used to check whether this power bank can live up to its claim, wherein it says on the specification that this power bank can produce 5 volts, 2 amperes of current. So as you can see, the output voltage is 5 volts DC and the output current is 2.03 amperes. Meaning to say that whatever the manufacturer claims for this device is true. Okay, as you can see on the rating of this power bank, on output number 2, the power bank can deliver 5 volts at 2 amperes. So this claim has been proven by using the USB doctor and of course by using the USB active load resistor. So let us go further. Let us try to see what is the limit of output 2 of the power bank. We will now set the USB active load resistor to a current value until such time that the voltage coming from the power bank will be less than 4.5 volts DC. According to the USB standard, the USB voltage is anywhere from 4.5 volts DC up to 5.5 volts DC. So any voltage below 4.5 is not good, and any voltage higher than 5.5 is not good also. So again, we will try to extract or consume a current until such time that the voltage coming from this power bank will be less than 4.5 volts DC. So we will now go further with regards to the output of this particular power bank module. Battery check, still 100% capacity. Now from the specs, USB number 2 output can deliver 5 volts, 2 amperes. USB 1 can deliver 5 volts, 1 ampere. So as I have mentioned a while back in the video, we will be going further with regards to the output of USB 2 terminal of this power bank. Connected the USB active load resistor to the USB doctor and to the power bank again. So we will try to monitor whether the output voltage 5.0 volts DC will become lesser once we go beyond the maximum current capability of this power bank module. Now from the specification, this power bank module can deliver 5 volts, 2 amperes at output number 2. So we will now go beyond that specification and try to see the limit. Okay, we are now at half of an ampere. 1 ampere. The fan switch on. Ready? 1.38 ampere, 1.4 amperes, 1.5, 1.6, 1.7, 1.8, 1.9, 2 amperes, 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7. Oh, as you can see now, the output voltage had dropped from 5.0 volt DC to 4.75 while producing an output current of 2.8 amperes. So let us go for, oh, have you seen that? Now that is an indication that this power bank have triggered its automatic output protection or overload current protection. So let us remove. Okay, so have you seen the output? The output automatically switch off at that particular setting of current. I think that is 2.8 amperes at 4.75 ohm, 4.75 volts. So automatic protection of the power bank module had kicked in, protecting the circuitry inside, the battery inside, and of course, okay, let us turn it back to a safe value. There you are. So meaning to say, this power bank module, okay, can provide a 4.78 volts DC output at 2.8 amperes, way beyond its specification, which is output number 2, 5 volts at 2 amperes. Okay, I think the power supply had been stressed because of some heat was generated on this part of the power bank module, but it is not hot to touch. A warm feeling. So that's it. I hope you have enjoyed this video. You can comment below, click the like and the subscribe button. See you again on my next video.